Okay, thank you for joining us. As part of the Space Summit, we have two wonderful speakers with us here today. I'm sure that you have heard much about them and are looking forward to hearing from them. So I will be brief in introducing this. We are talking about the internet and space governance. The internet and space historically being very difficult things to govern. However, as humanity pushes further past our planet and commercial interest expands, effective governance is very necessary to make sure that even in space, the internet is for everyone. With governance facing significant challenges, jurisdiction difficult to define, and state sensitivity, there is a context in which technologists can play a significant role in space communications, and standards bodies functions as quasi-regulatory functions. With this, how can we make sure that technologies, engineers, and researchers have a positive role for a future internet in space for everyone? With that, I'd love to introduce our speakers, or rather have them introduce ourselves, starting with Vint Cerf. Hi, Vint.
Hi there. Thanks so much for having me on this part of the Space Summit. I'm Vint Cerf. I'm Vice President and Chief Internet Evangelist at Google. But for purposes of this seminar, I'm also one of the members of the InterPlanetary Network Special Interest Group. I founded the organization in 1998, just as a project for the interplanetary internet was underway at the Jet Propulsion Laboratory. So I've been at Google for 20 years now, starting in 2005, and very active in space activities since the 1960s. And I'll turn this over to Kaneko for his introduction.
All right. Hello, everyone. My name is Yosuke Kaneko. I am the current president of the IPNSIG. It's really great to see you all around the globe. I just want to say a big thank you, first before start, to Ginny, of course, and Laura, Chappelle, Mike Snell. These people are really enabling us with this Space Summit. So thank you so much. Big applause. And thank you all for the outstanding speakers for this summit. We could have done it without you. So really excited to be here. Speaking about myself, I currently work at the Embassy of Japan in Washington, D.C. I am the first secretary and space attaché. My main work is really to promote U.S. and Japan's cooperation in the space field. But for the purpose of this session, I will be speaking as IPNSIG. So great to have you all and ready to dive in.
Before you start asking questions, Jenny, I want to just interact a little bit with Kaneko. First of all, Kaneko, before you came to the embassy and this first secretary position, you were at JAXA as well. So you have a significant career in space engineering. Can you say a little bit about that period of your career?
Oh, absolutely. Yeah. My career at the Japanese Space Agency, probably 20 years or so, I was heavily involved in human spaceflight activities, including the International Space Station. I was in the development phase and also in the operational phase as a flight director. And also I was engaged in Artemis and all other really exciting space exploration missions. That's a really short story about my career, but thanks.
What I find exciting to your experiences go back into the 1980s. Mine started in 1961 when I was working at Rocketdyne on the F1 engines for the Apollo Saturn V rocket. So my experience with the space industry has gone on for literally 50 plus years. And at this stage of the game in 2025, I couldn't tell you how excited I am, more so than I was as a young man working on the Apollo effort, now having a chance to look at a real interplanetary internet that we could build. It's engineering now, it's not speculation. Thanks, Jenny. Please go ahead.
Thank you. I think that's so fascinating. With both of you having such a history in this sector for space and networking, I'm wondering your thoughts on how we can apply those lessons from terrestrial internetworking and engineering to the new interplanetary network as it exists and as it will exist. What kind of lessons are we bringing forward?
Kaneko, if you don't mind, I'll jump in with the beginning anyway, to say that we learned some very important lessons from the internet experience. The first one was that it really helped a lot that the US government was funding the effort at the Defense Advanced Research Projects Agency. So we didn't have to scramble for funding particularly, but we got government support, and there has been government support for the interplanetary delay and disruption tolerant networking bundle protocol development as well. And that's been very helpful. We haven't had to go look for customers exactly, although as commercialization happens, that's going to be an increasingly important element of our attention. The second thing is that collaboration turned out to be essential to make the internet what it is today, and it will be necessary, and it is necessary to make the interplanetary system, the solar system internet, also a collaborative effort. We want multiple parties to be able to build pieces of that solar system internet and to make sure that they've adopted protocols that will be interoperable. And so a lot of the development work has been to assure that multiple implementations got tested for their interoperability and their reliability. The third thing I would say is that the internet started out as an experiment. We didn't know for sure it was going to work at all. It was the academic community primarily that did all that work and used it in its early stages. And at this stage of the game, we know that we are going to have to test the interplanetary solar system internet equally as stringently, because people are going to be relying on its operation. So fundamentally, this has to be as solid an operation as possible. And that means lots of implementations and lots of interoperable testing and testing under realistic conditions. So we've learned from the terrestrial internet that we have to collaborate, that we have to cooperate, that we have to have standards. And for many of the people who are looking at this from a commercial point of view, you have to have customers that are willing to pay for the services that you offer. Kaneko, what are your thoughts along those lines?
Yes, absolutely. As I've spoke about my career, I lived in the space community for a long time. Looking from the space community on the footage of the internet history, I see a lot of great components there that we can actually leverage to the interplanetary internet. Humbly speaking about the internet, I think there are like 3 pieces that we can really learn from. Number 1 is about the standards. This is all about basics, but having a single way of doing things is so powerful. If you look at the RFCs that was generated for the TCP/IP, UDP/IP, and all of that, these are really the foundations of the internet today. So back to the basics, I think we should have a common set of standards that works for all applications. We also have this bottoms-up process, the open forums at the IETF, and I think this was a really powerful tool. It's completely bottoms up. If you're interested, if you're enthusiastic about the protocols and everything, you're able to join, and everyone can come to the table to voice and make these standards. I think this was a great venue and a great governance framework that we had in the internet. What's the beauty, comparably to the space community governance, is that the internet is flat. Every time I join an internet conference, I always get this impression that everyone is so flat. There's no hierarchical thing. There's no top-down architecture or anything. Everyone has a say. So I think this multi-stakeholderism, this multi-stakeholder policy-making processes, and this discussion regime is really unique to the internet. And I think this is really comparative to the more sovereign state-driven governance scheme in the space community. But I think there's a lot to learn from the space side, what we can leverage from the internet side. So maybe 3 points: global standards, open forums, and policy-making processes. These are the 3 top things that I always reflect on.
This is really an interesting observation that you make. Of course, those of you who are listening or will listen to this know perhaps about the Consultative Committee on Space Data Systems. It's been around for a while. It's headquartered here in the Washington, D.C. area where both Kaneko and I live. But it is established as a nation-state level membership. The Internet Engineering Task Force is really peculiar because you can't be a member. There's no membership. All you can do is show up. And if you're interested in a particular working group, you just show up at the working group. That's unusual. That is truly flat multi-stakeholder and very exciting. And I think if we can allow those processes to work on behalf of the solar system internet, although recognizing that for many years, governments were the only sources of support for space exploration. That's starting to change now. NASA is asking commercial sector companies to offer products and services for space exploration and space utilization. But I love the idea that you can't be a member, you just have to show up. There's something very magic about all that.
Yeah, and one more observation around the multi-stakeholder thing is that if I recall correctly, it's the 20th year anniversary since the WIS's where it gave birth to this policy-making process. And I think it's a really great time to reflect upon our footage over the past 20 years and the real practice and implementation of this policy-making process. When we especially look at our future, we're trying to build this interplanetary internet, and I think we can reflect upon ourselves on what are the lessons and what we can leverage this great DNA that has really matured over the past footage of the internet.
Interestingly enough, if we look at ourselves as proponents of the solar system internet, we also have to recognize that we aren't the ones necessarily who will actually be constructing it. The construction will be done by governments and by private sector companies, but we have an interesting opportunity to facilitate that by enabling standards, doing testing, verifying the implementations and the like. It's a wonderful opportunity for all of us to contribute to this construction over a period of decades. I won't see the end of all this, but I'm having a wonderful time at the beginning of it, imagining what it could possibly be.
That's excellent. With so much that is brought from traditional networking and governance and the way that has come together as a community-oriented plan, with us bringing that to space networking, I'm also curious about your thoughts on how we're bringing the benefits of interplanetary networking back to Earth as well, and how that's influencing terrestrial systems.
Let's look at what has happened just in the last several years. One of the things you all know or will learn if you haven't already is that the speed of light is too slow. It takes a long time for signals to propagate throughout the solar system. And the connectivity is not very reliable because celestial dynamics cause troubles like planets rotating. We don't know how to stop that. So we have to wait until the planet rotates before we can talk to something on the surface, or maybe a satellite goes behind a planet. So this delay and disruption challenge is quite real. It turns out terrestrially we have similar kinds of experiences. Sometimes things like 5G and 6G or 4G are not 100% reliable. We lose radio connectivity from time to time, or there's radio interference that prevents the signal from propagating successfully. So we have that kind of problem. We also have situations where you're in radio shadow, like you're under a bridge or something, you may not get a signal. So this disruption occurs terrestrially as well, and some of the protocols designed to deal with that for the interplanetary environment will also support terrestrial applications. We have a particular worked example, which I'm especially pleased about. One of our colleagues, Samo Grasic, has been involved with the reindeer herders in the northern part of Sweden, the Sami tribes, and they have been experimenting using the DTN-style protocols with radio transceivers around the necks of the reindeer so we can track them. And of course, the connectivity varies depending on where the reindeer happen to go. And so the result is a delay and disruption tolerant design in order to capture that information for the reindeer herders. So it's a particularly unusual application, but it gives credibility to dealing with situations where there's radio interference or there's radio shadow or there are other kinds of impairments that prevent the network from being 100% on and 100% reliable. So I can imagine for Internet of Things, for sensor networks and things like that, where radio power is at a premium, we may have this kind of disrupted environment, and the protocols will support that.
Yeah, I completely echo with what Vint just said. TCP/IP is really based upon that you have connections end to end, but it doesn't apply for all the cases when you kind of think about the disasters or things like that. These technology can really be leveraged for disaster affected regions, or maybe undeserved regions that don't have any internet access, or other challenging environments that I can think of, like deep sea communications or polar comes or maybe inside caves. So I think there's a lot of variety and possibility there to leverage this technology.
Absolutely. At least personally within the IPNSIG, I've seen a lot of interesting implementations. We were researching this to help build out our library of different implementations, and truly I was astounded by how many different applications there are, and it makes me very optimistic. With this being such an important contributor to the future internet and connectivity to remote and nomadic groups, I was wondering your thoughts on how we can collectively ensure that in space, the internet remains for everyone. You mentioned the use of the multi-stakeholder model here on Earth, which has been so useful in making an internet that includes groups affected by it. But there are also stresses on the multi-stakeholder model because everyone wants their thoughts heard, and sometimes that makes community-driven governance difficult. With that in mind, is there anything that you would say for how we can support multi-stakeholderism in space governance?
Kaneko, would you like to start on that one?
Oh, yes. So I think we have this really bold vision that we want internet for everyone in space. I think that's an end state, basically, and I think we should work toward that. But it doesn't happen all at once. It's going to be a transitional one. So in reality, the space agencies build the space network backbone today, but it's going to transform to a more mixture of commercial capabilities and also government capabilities. And I think we're really on the cusp of seeing that right now. For example, space agencies procuring commercial services to send packets back and forth. In case this will be the bundle, of course. And then after that, in the real future end state, we might have a commercial backbone providing services for every user, including the space agency, the commercial sector, and also for academia. As the architectural change, the users will change based upon, and the architecture will change accordingly to the users. What that means is the governance structure would also transition accordingly. So multi-stakeholderism to me is like a real end state that we should really envision, which is analogous to the internet model. But I think it's a gradual transition. And I think the multi-stakeholders takes time. As I've said, the space community hasn't been working in that way for a long time. So it's really the time to infuse this concept right now in order to reach that end state is how I see it right now.
Thanks so much, Kaneko. That's a great preamble. Let me make a couple of observations. First, looking back at internet history, when we started out, we made the assumption that there would be more than one network. In fact, we had more than one network to begin with. We had three. We had the ARPANET, which was the granddaddy of all this, but a mobile packet radio network and a packet satellite network were needed for certain applications that involve mobile vehicles, ships at sea, and aircraft. So we started out with multiple networks, independently operated, but then had to have interoperability. So the standards were all designed around the assumption that there would be multiple networks and that they had to interwork. The same argument applies to the solar system internet. We anticipate that there will be multiple networks built. They may be built for a particular mission, for example, but the whole point here is to use protocols that can be made interoperable across multiple networks so that as time goes on and as missions complete, the assets of those missions could be used to build portions of an interplanetary backbone network. We've already seen examples of this on Mars. In 2004, when the Spirit and Opportunity rovers landed, we were supposed to be transmitting data back from the surface of Mars to the Deep Space Network on Earth, the 3 70-meter dishes operated by the Deep Space Network at JPL. Quickly discovered that we needed to do something different because the radios on board the rovers were, if I'm remembering history, they were overheating and we had to back off on the duty cycle. They were only going to give 28 kilobits a second in a direct-to-Earth mode. But it turns out we had sent orbiters, both the Europeans and the Americans had sent orbiters to map the surface of Mars before the rovers got there to help figure out where they should go. Those assets were repurposed and reprogrammed to become relays in the Mars network. And they have been supporting all the rovers that have landed since that time in 2004. So think about this for just a second. The whole idea is that even if there is an investment in communication assets, you want to make sure that that investment can be repurposed to support multiple missions. The design was done to allow the investment to be made that would eventually support multiple missions. The second thing I would observe is that when Bob Cohn and I were doing this work, recognizing that we anticipated more than the original 3 networks, we said we had no idea what the business models were going to be, and we didn't dictate any of them. We just said somebody had to pay for the cost of operating a piece of the internet, and people would figure it out. And if they didn't, that piece would go away. That was okay if it wasn't sustainable. So the same argument is going to be made for the solar system internet. There may be multiple pieces. They may start out as being wholly owned and independent and not even part of the solar system internet, but at some point, the party operating network should have the option of participating in supporting the interplanetary system. And so we want the standards to be there to support that, and we want the business models to be there that will support sustainability. So those are important lessons that we can take away from the internet. And in the long run, just as Kaneko has suggested, eventually we may have multiple networks that are serving various parts of the solar system, interworking with each other in order to support interplanetary communication across the solar system. Those lessons have been learned very effectively in the terrestrial network, and they can, I think, apply in the interplanetary version. The third thing, if I'm counting this right, has a lot to do with the idea that we should have a governance environment that contemplates this multi-network system with multiple operators. The core of that is the Artemis Accords. That's the first attempt that we've been able to make beyond the original Outer Space Treaty of 1967, which basically said nobody's allowed to own any extraterrestrial territory. I think that's likely to change with commercialization of space, but that's the current rule. Nobody can own any property off the planet. What we see in the Artemis Accords, however, is an expansion of cooperation and collaboration in a framework in which that can happen. And so nation states and organizations have signed on to the Artemis Accords, and it's my expectation that those accords will form the basis for treaty-like agreements. The Artemis is not a treaty, but it is a concord. It is an agreement among parties. Eventually, I hope that becomes a treaty-level object so that nation states and by implication, companies can become part of the treaty and mutually support the operation of a solar system-wide internet.
Yeah, Vint, I can't agree more. Actually, so around the Artemis Accords, there's right now this movement that there's this UN body called COPIUS. It's constituted by the member states of the UN, where you have to vote for a single policy or a guideline or a framework or something. But the Artemis Accords is becoming a real foundation for those discussions at the UN level. So we're seeing all that coming in place already. What I see right now when we look at multi-stakeholderism is that we need to bring in the private sectors to come to these discussions. It could be an informal, soft way of engaging first, because it's going to be a huge gap between our current way of working in space governance. But I think gradually we need to change that regime, bringing in the private sectors and have a say to the table, because these people are the actual builders of the SSI backbone, and that could be the future that we can foresee. So I see that as a general challenge that we see in space governance. But yeah, IPNSIG is really happy to facilitate these kind of coordination. Completely agree with your observations.
Before Ginny asks us another question, and by the way, the questions are wonderful, Ginny. Thank you for setting the tone and substance. I wanted to bring up something that I consider extremely important in this effort. If we don't have applications that use our underlying bungle protocols, nobody will be interested because nobody cares about the details of the protocols. They care about applications that they can use the system for, whether it's terrestrial or extraterrestrial. It's very important that we now start concentrating on applications that use the bundle protocol suite. We have several that are already either tested or are implemented and tested, and some are in already regular use because we've been on the International Space Station since, I think, 2009, where astronauts have been using the bundle protocols for control of experiments on board the ISS or interconnection with terrestrial assets, for example. But this whole notion of adding applications is really important. One of our IPNSIG members, Scott Johnson, has developed and implemented an email capability that would allow someone in an internet setting to talk to someone who is off in bundle protocol space and able to exchange email, which is, generally speaking, a delay-tolerant application. There are lots of other potential delay-tolerant applications, which might be control of scientific instruments and sensor systems, IoT devices, and things of that kind. But we've also tested applications where streaming video has worked very well. We tested things at very high bandwidths where they're available at 600 megabits a second on an optical link, for example, or in situations where the latencies are very low. One of our experiments was on the International Space Station, where the astronauts were literally in real time controlling a rover on the surface of Earth. I think it was in Germany, if I remember right. But the idea is the distance wasn't very far, at the speed of light anyway. And so real-time interactions were feasible using the bundle protocol. I think the focus of attention now has to be on an operational setting and an application setting for the use of bundle protocols in order to show people that adopting these standards are in fact useful to their missions. And so that's the focus of attention that I think we need to shift to in the latter part of this 2020 period.
Absolutely. Speaking of encouraging adoption and further development, here at the Space Summit, we have so many people here from all different groups, different sectors, different stakeholders. And one of the main questions that I would really love for your opinions on is what you hope for those currently involved in space networking or those looking to get involved. What you look for this community at this time.
I really think that there are an incredible number of different opportunities for people to engage here. There's the technical standards development activities in the IETF and the CCSDS. There's the application space, which is frankly wide open at this point. Lots of opportunities. We need a bundle API, for example, that makes it easier for people to build applications. We need proxies, for example, that could interface to internet, TCP/IP or QUIC-based applications going through the bundle protocol system to get to the other side, either to a bundle-ready system or possibly to an extraterrestrial internet. And I love that expression. The idea that there could be extraterrestrial internets sounded like science fiction until now it's a possibility. So all of those things are really important areas where people can contribute. But as Kaneko has outlined, we also have major policy questions that need attention. That's less about technology than it is about how you manage common resources. How do you treat internet as often seen as a global commons, as a public resource? And although I think the solar system internet is likely to be limited in terms of public access to it, because its capacity won't be anything like the terrestrial network, certainly not in the near term, it still should be the case that those who are authorized to use it are freely able to get to exercise its assets and be available to the extent that the operators of the various components of the solar system internet are willing to share those resources with others. It's not wrong, for example, for a private sector company to say, I have a limited amount of resource, some of it I'm going to dedicate to whatever project I'm supporting or need to support, but other assets might be shareable. And so I can imagine a kind of mix of things where some of the nodes of the bundle networks are available to others and others that are dedicated to a particular corporate or perhaps a particular mission exercise. So we need a lot of flexibility in the system to allow these different scenarios to be implemented in a way that is operable and reliable.
I completely agree, Vint. So while Ginny is looking at the chat box and figuring out which questions to ask, if I may steal the moderator position for a little bit, when I always talk with the space community, what is multi-stakeholder governance is sometimes a question. It's a very abstract concept, and I'm trying to convey and explain what this is, and it has been so beautiful. But Vint, from your experience, would you be able to share us with a good example, a success case of how the multi-stakeholder policymaking process really flourished? And a good case would be a good way of making a case and giving the story of how effective this process will be.
I would say that the Internet Engineering Task Force is probably the closest I can come to a prime example of multi-stakeholder processes, because it's all bottom-up. The working groups get established because there's a bottom-up demand for them. We have birds of a feather sessions to decide what working groups are set up to do what kind of work. It's true that there is some process now involved that's a little more formal than it was when things were set up 40 years ago. So there is an Internet Engineering Steering Group, but those parties who are running the areas of the steering group are elected by the participants in the IETF. And so it is still a bottom-up process where people gain authority because others want to give that to them. The decision that something is a standard belongs to the Internet Engineering Steering Group. The area directors help to shepherd the working group efforts to the point where it can be presented to the IESG if, in fact, it is to become a standard. So that's a really prime example. Now, another organization which has also attempted to use multi-stakeholder processes is the Internet Corporation for Assigned Names and Numbers, which was started in 1998. In that particular formulation of multi-stakeholderism, there were groupings of people who were in the commercial sector, in the academic sector, in the technical world, and so on, and government. In that case, the groupings were a convenience so that we had some idea of who the stakeholders were and what their interests were. To be quite honest with you, I'm not 100% sure that kind of grouping always works, because we're seeing, especially with commercialization of the internet, more and more organizations are covering multiple groups. Some of them are domain name operators, some of them are internet service providers, some are application service providers, some of them are all three or four. My company at Google, for example, covers quite a bit of territory of interest to the Internet Corporation for Assigned Names and Numbers. So that particular experiment using these sort of fixed groupings has taught me a lesson, which is that maybe you should be more flexible. In the IETF case, the groupings are the working groups, and they're focused on a particular problem to solve, and anyone is permitted to participate, regardless of whether they're in the commercial sector or academia or government or something else. So I think we've learned some lessons about different ways of formulating multi-stakeholder processes. The Internet Governance Forum is another example of the introduction of multi-stakeholderism thinking into the United Nations processes, because as you mentioned earlier, the Internet Governance Forum spins out of the World Summit on the Information Society in 2005, which formed a working group on internet governance, which tried to figure out what is it and how do you do it? We didn't get an answer by the end of what's this, in 2005, so we essentially created the Internet Governance Forum to continue that discussion. And here it is 20 years later, and we were still talking about how do we govern the internet? The answer is carefully, with considerable care. And we're still learning. And the reason we're still learning is because the internet keeps evolving. The technology keeps changing. The application space is dramatically shifting, especially now with the introduction of artificial intelligence and AI agents and large language models and all those other things, in addition to everything else that's been going on. Social media, cloud computing is all part of that gigantic internet governance territory. We're still learning how to do this well. And I think we should pride ourselves on accepting that we need to learn how to do this better across quite a different number of application areas, including the solar system internet.
Wow, Ben, that's a lot of substance there, a lot of lessons, a lot of valuable inputs. I think the space community would love to hear that. The real practice and the experience and the success cases and what we've learned so far. I think the space governance community will really benefit from these kind of talks. I would love to engage with the United Nations and the copious body in the future. So thanks so much for sharing. So back to Jenny. Sorry for stealing.
Not at all. This is great. With talking about these different stakeholder groups and how they're defined, as well as the history of the internet terrestrial and what we learned from it, there seems to be some agreement that the commercial interest is going to be a really considerable driving force in the early development. With that in mind, I would bring up a question from the chat. Berna asked about what private companies are involved at this moment and where to find information. I'd also point out there's already been a few responses in the chat from Scott J. and Alberto and Lee. So thank you to our community. But I was also hoping to get our presenters' thoughts on commercial involvement at this point.
I can mention a few that I know about. Spatyam has already been mentioned in the chat. The second company that comes to mind is Illyria, which is a spin-out from Google, and it has a remarkable capability called Spacetime, which is a routing system for very complex environments, satellite-based environments, solar system internet environments where connectivity is not always assured. TVR work, the time-varying routing work that's going on in the IETF is relevant to that sort of thing as well. So that's the second one. The third one is Intuitive Machines, which is a company that has launched and successfully landed some equipment on the moon, although it's true that they had a little bit of forward motion there, and then so they kind of landed in a tilted way. But the fact that a private sector company has landed assets on the moon is really quite remarkable, considering where we started many years ago. So those are three that come immediately to mind. There were probably others that I don't know about or just failed to mention. Like, oh, can you think of some? There are some coming up here on the chat as well. I'm sorry, 3DTN or whatever it's called is another one that is building software for delay and disruption tolerant networking. What have I left out?
I would just add that there are major telco companies like KDDI and Nokia. They're trying to deploy a cellular network on the lunar surface. So these are really the big ones. Also, I would mention Fujitsu. It's a printer company and it has a lot of software businesses in their portfolio, but they've been working very long on the DTN development. So I would raise Fujitsu as well. iSpace is another a very significant asset in Japan, where they are actually not only for comm, but actually they're trying to do Eclipse-like mission of delivering cargo to the lunar surface, as well as mining business. And also they have plans to deploy cislunar communication capabilities. So I can just think of these 4 or 5 names on top of what Binta just put out.
I see Gary Barnard has also mentioned XISP-Inc., working on interoperable networking communication architectures. INCA, clever acronym. And there is also Scott Johnson's work at Spacelay Packets. He's done some significant implementations, particularly recently of email for bundle protocol applications. And Lee Torgerson at JPL mentions that JPL is actually operated by Caltech and not directly by NASA. Also, Thales and Boeing and Grumman are all examples of private sector companies that are interested in this area. And the Advanced Physics Lab at Johns Hopkins is also deeply involved with the development of a bundle-based router for a variety of applications. So we're seeing a substantial implementation energy going into the kinds of assets that would help build the solar system internet.
Fantastic. And I would like to confirm that the chat from this session will be linked to the YouTube video for it on the IPNSIG YouTube channel. With that, and especially acknowledging how many people in the chat have responded to this question as well, it is very much appreciated. This is a community effort, so that's very nice to see. I want to thank Vint and Kaneko, as well as the attendees, for being here at the IPNSIG Space Summit and being part of this community. So thank you.
We appreciate the opportunity to engage. And of course, we're looking forward to all of you who might not already be active in the InterPlanetary chapter of the Internet Society to join us in this fantastic and exciting new enterprise, which I think will continue on for the rest of this century.
Mm-hmm. And I would just add that thank you for participating. And we still have a lot of rich programs on our portal website for the summit. Please stay in touch. And I encourage you to come on board because this is such a fascinating project. SSI is just really the way to go. Thanks so much for joining, and I hope to see you around. Thank you.
This is what engineering is all about, turning science fiction into reality.
Absolutely.
Perfect. Thank you.
All right. All right. Bye-bye.